Hello and welcome to all my dear students. Students, in today's lecture we are going to continue chemical reactions of amine. So let's start. First, we'll discuss about structure-basicity relationship of amines. Yes, friends, the basicity of amine is dependable on structure of amine. Basicity of amine is related to their structure because we know that different amines have different number of alkyl group present in them and different number of hydrogen present in them. And we know that alkyl group is electron donating group. The effect of alkyl group is plus I, positive inductive effect. So as number of alkyl group increases, it will affect the basicity of different amines. So basicity of amine is totally dependable on structure of amine. It depends on the ease of formation of the cation by accepting a proton from the acid. Yes, if we'll discuss the basicity of amine, it is totally dependable on stability of cation formed after protonation of different amines. More stable the cation, more basic is the amine. This is the most important funda. Now let me explain you first. We are talking about basicity of amine first in gaseous state. Yes, friends, we are talking first basicity of amine in gaseous state. First, if we'll compare alkanamine, compare alkanamines, comparison of alkanamines versus NH3. We are comparing alkanamine with ammonia. Now, in ammonia, we know that nitrogen contains a lone pair of electron with 3 hydrogen present. This is structure of ammonia. Now, if we'll replace one H by alkyl group, we'll get primary amine, that is R, NH2. The lone pair of electron won't change. Now, if we'll write 2 alkyl group, then this is secondary amine. If we'll write 3 alkyl group, again friends, this is tertiary amine. So we can see that as we move from ammonia to primary to secondary to tertiary amine, number of alkyl group increases. And this is the simple funda in organic chemistry that plus I, plus inductive effect increases, basicity increases. Again, if plus I increases, then basicity increases. So we can see that in ammonia there is no R present, no alkyl group present. There is one alkyl group. There are 2 alkyl group in a case of secondary amine, and there are 3 alkyl group in a case of tertiary amine. So friends, as number of alkyl group increases, electron donation increases, and you can see that if this alkyl group will donate electron, then availability of electron on nitrogen increases. So it will donate electron more faster, more easier. And as the ease of donation increases, we know that basicity also increases. So this is the first concept to understand basicity of amine. Let me make a point. Basicity, come on, I'll write here, come on. Basicity, I'll write here, basicity is proportional to plus I and inversely proportional to minus I. And we know that R, if R is alkyl, then alkyl has plus I effect. So as number of R increases, basic strength increases. Okay, my dear friends. But please do remember, we are talking basicity of amine first in gaseous state, because liquid state, in a liquid state, there are different fundamentals. So this is the first concept. Second concept, second point I had written over here, that is, if we'll add H plus in the structure of amines, then we'll see stability of positive charge on nitrogen. If the positive charge on nitrogen is more stable, more will be the basic strength of amine. Let me make a point. First, we'll add proton to each and every amine and ammonia. If I'll add one proton, I'll get NH4 plus ion. Now, if we'll add one H in a structure of amine, we'll get R NH3 plus. Now friends, if we'll add one H in secondary amine, we'll get R2, R2 NH2 plus. And friends, if we'll add one H in tertiary amine, we'll get R3 NH plus. Now we can see that more number of alkyl group means more stable the positive charge on nitrogen. Again, because here we already studied that, I already mentioned that if number of alkyl group increases, alkyl group will donate electron and it will, what it will do? It will make available electron on nitrogen for donation. And availability of electron on nitrogen increases donation, so where's basicity? Now in this case, after protonation, we can see that this positive charge on ammonium ion cannot disperse at all. But in a case of primary amine, the positive charge can disperse over alkyl group, so it will stabilize as compared to ammonium ion. But if we'll see the structure of protonated secondary and protonated tertiary amine, we can see that this positive charge will maximum disperse because of presence of 3 alkyl group. So as the dispersion of positive charge increases, it will become stable, and as the stability of positive charge on nitrogen increases, basic strength increases. So let me make a point. Order of basicity, order of basicity in gaseous state, in which state? In gaseous state follows which order? Tertiary amine is more stable than, then secondary amine, and then at last primary amine. So this is the concept behind basic strength of amine in gaseous state. Now I'll talk about basic strength of amine in aqueous state. We'll discuss basic strength of amine in aqueous state. In aqueous state. Aqueous state. Now friends, in aqueous state, if we need to understand the basic character of amine, we have to understand the solvation effect. Yes, solvation effect. We can see that there are different number of alkyl group present in different amines. As number of alkyl group increases, solubility decreases. So solvation decreases. And as the solvation decreases, basic strength of amine in aqueous state decreases. If I'll write protonated primary amine R NH3 plus. Friends, we can see that there are 3 hydrogen present. So it will hydrolyze by 3 water molecule. Secondary, protonated secondary amine. It will hydrolyze by 2 water molecule. And last, protonated tertiary amine. It will stabilize by, come on, 1 water molecule. So, to understand basic strength, first we need to understand solvation. We know that, again I'll repeat, as number of carbon or number of alkyl group increases, solvation decreases. We can see that in this case, in a case of primary amine, it is maximum solvated, then secondary and then tertiary amine. So, solvation increases, basic strength increases. Now, there are different fundas because let me remind you, there are so many exceptions in basicity of amine in aqueous medium. Now, this exception are due to steric hindrance of alkyl group. First, let me write the general order of basic strength of amine in aqueous state, that is primary amine is maximum basic strength, then secondary amine, and then tertiary amine. Now friends, as I told you earlier that number of carbon increases, it will affect solvation. We know that number of carbon increases, solvation decreases. So number of carbon increases, it will affect H bonding. So in methyl substituted and ethyl substituted amine, we have to remember an order of basic strength of amine. Friends, methyl group will not affect H bonding, but ethyl group will affect hydrogen bonding. So we have to remember 2 orders. First one is ethyl substituted amine. It follows the order of secondary ethyl substituted amine is highest basic, then tertiary ethyl substituted benzene, then primary ethyl substituted benzene. But in the case of methyl substituted amine, secondary amine is has highest basic strength, then that of primary amine, and at last CH3 thrice N, that is tertiary amine. So we can remember by this way 2, 3, 1 and 2, 1, 3. 2, 3, 1 in a case of ethyl substituted amine. In liquid state, please remember, we are talking about aqueous state. And in ethyl substituted amine, it follows secondary, then primary, then tertiary. I hope it is clear to all of you. Now, let me summarize this lecture that if we want to understand the basic strength of amine in gaseous and liquid state, we need to understand 3 fundamentals. First is inductive effect, second is solvation effect, and third is steric hindrance. I hope it is clear to all of you. In the next lecture, we'll discuss aromatic amine and ammonia. We'll compare aromatic amines versus ammonia. We'll compare aromatic amine with amine and ammonia, and we'll do some questions. Friends, please like our video, subscribe our channel if you had not subscribed yet, and forward our videos to our friends. Thank you friends for watching this lecture.